Okay, so now we have this. This right here is what would be considered a type constraint. It already exists. Another example of type constraint would be um if I wrote a function, just run func add nums, right? And no matter what regardless of what type, whether it's a float, double, or integer. Right now, when I just create this, a b returns int, right? Return nums, let me say nums, a and b, which is 3 plus 5, which is 8, right? However, it's right here. Custom constraint example, custom constraint, type constraint examples. Constraint examples. Examples, right? So right here, type constraint example. So now what you need to do is, you see this right here? You see how this is it takes an int. We can change that, right? T numeric is another constraint. So it makes sure that whatever is passed to this is numeric, and it can be dealt with the plus sign, right? T T turns T. So it's still 8, right? However, if I say 3.2, 3.3 or whatever, 5.7, this is a double now. But it adds this 0.8. Okay. Because I wanted to return a double, 9.1. Okay. You see that? 9. Okay. There we go. See, this returns a double or a float or whatever. So yeah. 0, 0, 2, 1, 5. Okay. But we can do that just with an int. And so now let's talk about some um let's talk about another example of a type constraint, okay? Get even a little more. I'm gonna put this in the context of an object, okay? Okay, so I'm gonna create let me do this. Herb knock this out, okay? Enum, which I'm gonna show you how to do this later. M Lambo models. L models, and this stands for Lamborghini models. We're going to create objects of Lamborghinis, right? Now I'm going to tell you how to create a generic type, and yeah, trust me, okay. So where it compares them, okay. Um, let's do this. Let's make Sorry about that. Make no equal. Make is of type string. And that should be LAMBORGHINI. No, I'm sorry. Case. Then the door. I don't know what I was in case. Hurricane. Is that how you spell hurricane? These are different models of Lamborghini. Case. Russ. It's an ugly SUV that Ferrari has. A Senza. Case. Cyan. This is like the one that's a couple $1,000,000. Yes, there is a Ferrari that is a couple million. Okay. Those are the models. Now let's create the struct for Lamborghini. STRUCT LAMBOR Lamborghini. Oh, I hate when I do that. Lamborghini. And I'm going to, before I do that, let make, because make is always going to be Lamborghini. So, LAMBORGHINI. Okay. Let model equal type. Yeah, first of all, this should be string, right? String. Jesus Christ. Model. L model. Okay. L model. L model. Okay. And let's say price is I don't know why this would be var, not there. Var price is of type double or is of type float. Okay, not float. All right, this is good enough. And of course, this is comparable, right? And if I want to find what's comparable, I will go into the definition right here. This is the signature. You see how I go in there? Click on the definition, go in here, and then I copy, right? And then I just want to compare the price to the price, right? Return LHS dot price less than RHS dot price. And that's it. And now I can go ahead and create these these different Lamborghinis. Lamborghini model dot Aventador. What's the price? The price is $393,000 for the Aventador. That's right. Right. You get a good job as a senior developer, you can buy one of these things. Right. And the Hurricane is 327,000. The Urus, 200 something thousand, 225,000. Urus is 225,000. Let's Asenza equal Lamborghini Asenza, which is like millions. 3.6 million to be exact for a car. Yes. Right. So now we're gonna say L, let's L array equal Vin Hurricane Urus Senza. Okay. And what I want to do is get the highest price. Again, so if I want to make this so that it's generic, all I have to do is make it so that it's comparable, right? This conforms to comparable. If I have another object that conforms to comparable, I can compare them as well. Take an array of them and put them into this function as well. So I'm gonna say func get highest price, right? And I'm gonna say array of type T, right? That's what it is. It's an array of type T. T. And what did we conform to? Comparable. That's our constraint. So anything is comparable that conforms to comparable, we can compare them. and we return an item of type T. And which is very easy. Array return array dot sorted dot last and so now I'm going to take this and say get highest so this is the highest right here. Aventador, which is not the highest. It is so not the highest. It is so not the unless I put this in wrong. Of course I put it in wrong. I have this 3, or maybe I'll put in some extra zeros in here. The Aventador is 1, 2, 3, 1, 2, 3, 3,900. 3,930,000. So yeah, so that's the reason why that's higher. Really, it's supposed to be the Asenza. It's supposed to be the highest, right? Of course, 3,600,000. So and of course you can take any array of anything that conforms to the comparable, like this array does, right? Like these objects do, and you can put them in there. And if you have, you can create another a protocol where of different types of cars that conform to a particular type, say vehicle, and they're all comparable, then you can, you can sort all of those. All of those can be passed to this array because it conforms to comparable. um, yeah. Um, so let's see. Um, let's talk about custom constraints for generic types. So I'm gonna say a custom constraint for a generic type. Actually, we'll start on a whole new different screen and start clean, and I'll be on to the next. We'll be talking about custom constraints for generic types.